You started? I hope so. Okay.
Yeah, it's recording.
Yeah. So today we have an interesting topic that is large language models and control mechanisms improve text readability of biomedical abstract. It's a collaborative work between MMU and so we call it Manchester United. So initialized by Max, who said
actually Gordon told us.
Yeah, so how want to do this plug shared task, plain language adaptation of biomedical math abstract. So Sam and Nicolo is from this building that is eager to do this task as well. So they did across this summer for more than 2 months, since beginning of July. We had around 3 months meeting about this project, and we got a really good or interesting results. So we want to present, and we also have the paper link on archive there, and we will upload all the codes and the pre-trained models or fine-tuned model if people want to use. And for this talk, I will briefly mention and then give Jeremy and Sam to talk about what they did. Okay, let's
Control Shift 5. It's been blocked there. Up top right corner, there's a show. You can just that slideshow there.
It says who can see this transfer?
No, I mean you can just click the slideshow on the top right corner.
You can do anything.
Slideshow.
Yeah. It's been blocked.
Yeah. This one. Show.
I click it. I got it.
Yeah.
This one.
Yeah.
Great.
And Nicolo is here.
Oh.
Okay, that's good. So in this talk, we first introduce the examples about this task, so you know what it's going to do. And then methodologies, followed by what model we investigate, including a couple of state-of-the-art NLP models. Then we introduce automatic human evaluation and summarize some interesting findings. So here is the example. Sam, you want to talk about this?
So these examples come from the task organizer, Plaba, which shows the goal of this research, which is to do some plain language adaptation of biomedical abstracts. So in the table, you can see any input or abstract, which is some complex biomedical abstracts. And as output, we're trying to simplify them for average, like normal people to be able to understand them. So we give here a few examples of what the model would be expected to create. It would be expected to do some sentence structure simplification. So for example, removing some pieces of information which might not be very useful for understanding, and also doing some term simplification. Here, for example, we replace pharynx with throat, and also some simple paraphrase and synonyms replacements.
Maybe you can give us a bit more examples just for everyone, maybe read them.
So you also see that, for example, for sentence structure simplification, we remove some information in parentheses in the second example. For terms,
can you read out one of your simplified
of course.
abstracts?
So there is, for example, we remove also, okay, I will read the full one and then tell you what we remove.
Yeah.
Several viruses and bacteria can cause acute pharyngitis. However, Streptococcus pyogenes, also known as Lancy-Field Group A B hemolytic streptococci, is the only agent that requires an etiologic diagnosis and specific treatment. So
The simplified one.
we simplify it with the following.
Bugs give you a sore throat.
Yeah. Many viruses and bacteria can cause short-term sore throat, which is a term simplification for acute pharyngitis. However, group A strep, which is the replacement for what was in the parentheses before, caused by group A strep bacteria, is the only cause that must be identified based on signs and symptoms and treated, which is a replacement for is the only agent that requires an etiologic diagnosis and specific treatment. So if we want to also talk about the first example, which might be a bit easier to understand.
Okay, read it.
Acute pharyngitis tonsillitis, which is characterized by inflammation of the posterior pharynx and tonsils, is a common disease. So I replace acute pharyngitis by sore throat.
Read the output.
Yeah, so sore throat, tonsillitis, or when the back of the throat or tonsils is inflamed, it is common. So we replace basically all pharyngitis and pharynx by throat. We also replace posterior by back and acute by sore. We also remove some sentence structure, for example, which is characterized by, we just remove it because it's not very useful for understanding the sentence.
Isn't acute better replaced by very?
Well, this is an example from the BLABA data set. So
Yeah, this has been adapted by their professional or annotators, so it's just more like demo.
So acute pharyngitis is replaced by sore throat.
yes.
This example displayed by shared task organizers, and this is what they want the language model to achieve to do this task. And then we will show you later how the language model is doing interestingly in different way. Clear the task?
Yeah. Can we raise some question?
Yeah, I guess very acute could be replaced by very, but not in this context, right? Acute pharyngitis couldn't be replaced with very throat.
Or very sore throat.
Very throat, yeah, very sore throat. Yeah. So it's actually interesting. So pharyngitis is probably sore throat anyway.
Yes.
Yeah. So acute is basically just ignored.
Mm-hmm.
Yeah, because you could have mild pharyngitis.
Mm.
Yeah, when we check some of those terms by dictionary because we didn't understand either, we realized there are some kind of repeated
Yes.
saying things. Yeah. Good. That's good. People start to discuss about from the beginning. That's a good sign. Okay, let's go to the. Yeah, so this is a data set from PLAB 2023, and the original data is published in January of this year by Atal, and it is from 750 abstract from PubMed, if I remember correctly.
Yeah.
Each manually adapted to plain language by at least one annotator for a total of 7,000 plus sentence pairs. And then complete guideline is in their website. Here they listed three notable ones. One is called split, another is substitute, and third one is explain terms. That is what they suggested the task should be approached by. And then for our methodology, Niccolo, would you like to mention this part?
Sorry. Before you move to methodology, have they at all published the inter-annotator agreement here, or have they measured it?
Sorry, go and say again.
Inter-annotator agreement. So because they need to
yes.
summarize things, have they measured that?
I think in their paper they have, if I remember correctly.
Okay, and that would be interesting to know.
Yes, and also read all paper were linked to their paper, and there's annotated agreement level. They achieve much higher than ours. We also did the human evaluation. Yeah.
Okay.
Yeah.
Thanks.
Good. Yeah. Okay. So I mentioned it. So for the methodology, we choose three kinds of model. One is encoder decoder. That's the encoder decoder including T5, Sci5. T5 is from 2020. Sci5 is based on T5 trained on biomedical data. And then another model encoder decoder base is called BART in the bottom. We make a star because instead of using pre-trained BART, Jeremy continually train the BART with wiki large data. That's correct, right? And then Jeremy also applied the control mechanism that he has been developing for his master thesis on top of BART stock, let's say.
Yeah.
So T5 and Sci5, Sam developed this, and Nicolo tried ChatGPT, GPT-4, and fine-tuned GPT model for our task. So we use train validation data for this model, except for one-shot ChatGPT and GPT-4. And then after we deploy them on testing site, we choose two best performing model according to automatic scores. Then we carry out human evaluation. That is general pipeline. Is it clear? Cool. So let's see what model we applied. Here we mentioned encoder decoder T5 Sci5, GPT-based model that's only decoder-based model. That is GPT 3.5, GPT-4 from OpenAI. And BioGPT is from a Chinese institute that's trained from scratch based on GPT-2 structure, because they want to avoid the pre-trained general knowledge, then fine-tuning the domain. And then control token mechanisms is developed by Jeremy.
Yeah, so I fine-tuned by GPT models. So in particular, BioGPT is decoder-only model, so specifically for text generation, and it's built upon GPT-3. But the training data is in the medical domain, so it's trained on 50 million PubMed abstracts. And instead for ChatGPT, we use a one-shot prompt. So we gave that you can probably go next slide. Well, yeah, so for ChatGPT, we use a one-shot prompt. So we first give some guidelines to ChatGPT, and then we give an example of how it should simplify the text. For example, we mark post-operative swelling as rare, and as you can see in the simplified version, it's saying swelling after surgery. And then there is the sentence later. We consider that was a bit intricate, a bit complex, and so we tag that as you need to rephrase that sentence, and then we show in the simplified version that the sentence has been simplified. Yeah.
I will not discuss about T5 and Sci5. So T5 and Sci5 use the transformer architecture, which has been proposed in 2017 in the paper Attention is All You Need. They are both designed for sequence-to-sequence tasks, so it includes multiple tasks such as summarization, question answering, classification, translation. For our purpose, we use the prompt summarize because we believe it matches our task quite well. It's important to also note that they both use the same vocabulary, the same tokenizer, which is a sentence piece tokenizer, and the same loss function. So the main difference between T5 and Sci5 is what they've been pre-trained on. While T5 has been pre-trained on the common crawl corpus, which is about 750 gigabytes of clean English data, Sci5 on top of this has also been pre-trained on biomedical domain, which includes, for example, PubMed data, but also some other biomedical data.
Yeah, now comes BART section. So BART is basically designed to solve the problem from BERT and GPT, who tried this by providing a mixed token masking strategy, including the deletion, span masking, permutation, and rotation and of sentence. It also provides both left word and right word context in the encoder, so we can better understand the relationship among the sentences. In the sentences. And this is published before T5, as I remember, so it's generally it performs slightly worse than the T5, but we found that it's proper for the control token mechanism. Yeah. So for control token mechanism, it's kind of like a numeric prompt. So we follow the definition, follow the design of mass and have this for kernel tokens, which are called dependency tree depths and word rank, and replace only the visiting distance. The last one is length ratio. Each one comes with a specified token, which has been added to the tokenizer, and comes at the end there is a value which is being represented in X, and each of these kernel tokens represents one characteristic of the sentences. The first one is syntactic complexity. The second one is lexical complexity. The third one is the inverse similarity of input and output at the letter level. The last one is length ratio of input, output, and output. So before fine-tuning, we have to calculate these kernel tokens and their values, and append these values to the beginning of the preprocess of the training data set. And then we use this preprocessed data set as a training material. After that, the model can understand the meaning of these values and kernel tokens. So based on this modified BART, which has been trained on Wikilarge, we can control the statistical characteristics of the outcomes. Following a similar process on Wikilarge, we do this on the PLAB dataset, and we also try to find the best value to maximize the SARI score, which is one of our main metrics on the validation set. So then we lastly test it on the test set.
Okay, you set out it.
Okay, so for the data setup, originally we have 75 healthcare questions, and for each of the questions we have 10 PubMed abstracts to answer these questions, and then they split this abstract into sentences and try to manually annotate this with professional annotators. At the end, we have 7,600 sentences pairs in total. And firstly, we remove the 1 to 0 sentence pairs, which means this sentence has been deleted because the annotator think is not very helpful for users to understand this. But because they are only rare, around 50 to 60 sentence pairs that is 1 to 0, so we think it's better for us to delete this pair, so we can, because it's hardly to learn from this, so with such rare sentence pairs, and we decide not to touch with this.
The deleted one, is this already a simple sentence? Is 1 to 0, or what's the other situation?
No, I think they just think it's not needed in the simplification.
Okay, cool.
Yeah, so after deletion, we try to aim for the 8.1.1 ratio, but as there are some of the sentences, they have two adaptations. So we try to keep these sentences as, because for our metric, it's better to have multi-references in for this to evaluate this. So we decide to keep this sentence pairs with multi-references in the validation and test sets. And lastly, we have around 1,700 sentences in the training set, and around 800 in the training and validation set. In the validation and test set.
Automatic evaluation metrics, Sam.
So I will introduce the metrics we use in the automatic evaluation. So they are distinguishable in two different parts. There's the n-gram overlap metrics, which evaluate simplification quality to reference. So for this, we use three metrics, namely bleu, rouge, and SARI. So bleu is precision focused. So it measures the n-gram overlap with the reference. And rouge also does the same, but is recall focused. And then SARI, which is a metric which has been imposed by the PLABA 2023, considers both precision and recall. And also on top of that, the output to reference length ratio. Then we also use a train metrics in BERT score, which evaluate the meaning preservation after simplification. So basically what BERT score is doing is evaluating the semantic similarity between the generated and the reference text. And for that, it's using the BERT embeddings.
So here's our evaluation output from the automatic scores. From here, you can see T5 small, T5 large, T5 base, and flan T5 are both tested. But for flan T5 XL, because too large, we use LoRa, that is efficient tuning framework for this model. And then Sci5 base and Sci5 large are tested. For BERT, we also tested a BERT base with control token mechanism and a BERT large with control tokens. And we can watch the GPT model later. So if we look at the table 1 on top, you can see T5 small actually was successfully fine-tuned in this domain. It generates the highest blue rouge scores, comparing the overlap between generate and reference. And then T5 base has the highest BERT score, that is semantic similarity in embedding space. And the BERT large with control token had the highest SARI score that is used by the shared data organizers. And then if we look at table 2, that is GPT models with one-shot GPT 3.5, GPT 4, and a BioGPT that is trained using PLAB data, also use LoRa because it is too large for us to run. You can see SARI score is 40 plus for GPT models for 3.5 and 4. And then BERT score for BioGPT large is 60 plus. So either GPT one shot or BioGPT didn't warn the T5 and the BERT model on both metrics in this comparison. So that's why later we will not pick GPT model for human evaluation.
Can I ask a question?
Yes.
So why do you only use one shot for the GPT? Why didn't you use the full training data?
So GPT has got a context, right? So the prompt can be, you can't give the whole training to GPT. So for now, we just try to do one shot. I think for the final paper, we'll do few shots. So it's not going to be just one example. It's going to be a collection of them. But you can't give the whole training to. You can't fine tune ChatGPT.
Okay, because if that's the case, then it's maybe not fair to compare GPT with the other model you use, because for GPT it's still few shot learning, and for the other one is fully supervised. So
yes, we want to put it here because we want to see how it's performed, and the people are eager to know about GPT models. So we want to see. Actually, here, even though it's one shot, it got 40 plus, even though it's 42, 43, not like 46. So it performed relatively comparable, even though it didn't win. So we want to see how good it is. And then for BioGPT, it's trained, right, Nicola?
Yeah,
fine-tuned.
Yeah, it's fine-tuned. Using PLAB data. Maybe PLAB data is not big enough for BioGPT to fine-tune successfully, or maybe this SARI score doesn't work too well. That's both doubts for here. Yeah.
but I think here you can make an average column to average all of these score. There is maybe easier to look. So basically, when you have a lot of evaluation metrics, people will base on the average.
We can, but there's also a doubt. For example, blue and rouge are precision record-based metric. And SARI, of course, is also a lexical thing, right? But this BERT score is embedding space, right? It is different kind of metric compared to lexical.
Yeah, I know, but just make an average, because here the higher the score, the better the model. So it's just the same trend. But anyway, just a comment.
Yeah, that's good comment. Actually, Sam averaged all this score in another project.
Okay.
Or synthetic generation project. And Goran was asking, why do you need to average them?
Because when you compare among different model and you have a lot of evaluation metrics, yeah, you can blame based on the average one. But anyway,
Yeah, but I guess I guess the problem is that these metrics may not be additive, right? So and that's why making an average may not make sense. So instead of that, we actually looked as kind of qualitative analysis. So if something is good in one metric and also in others, then it's good in any combination of the two. So we tried to avoid, because I think, I'm not sure whether you can really average rouge and blue because they measure different things, and in particular bird score.
Yeah.
Yeah.
I have a question.
Yes.
So is SARI based on blue and rouge?
No, it calculates itself.
Oh,
Yeah, it's however it's based on precision and recall also.
We'll add the library next time.
We cannot, it's multi-reference.
Yeah, and that's good. So let's move next slide. So to here is the best performer of each model. We also draw a learning curve of them. And Sam, do you want to mention brief?
So sorry, Fang, just coming back to this averaging thing. So what is the official score for the competition?
Sorry.
Sorry.
Yeah, they said it's for automatic evaluation. SARI score is the first choice, and they will then, based on SARI score, they will do the human evaluation.
Yeah. So you should then rank things based on SARI.
Yes.
Yeah. So that should be the main.
Yeah, that's what we did in the human evaluations.
Yeah. And so this evaluation that you have here, so that's on your test data, not on the official test data.
Yeah, they haven't released.
Yeah.
So,
but these are not official results. These are official results on your test data set.
Yes.
Yeah.
Data set that you call test.
It's on the PLABA data set.
Yeah. So for the shared task, the training data they release for the teams is PLABA data set. Actually, it's also public test site. So we can do it. And then for the system submission, they prepare a separate test site.
Yeah.
Yeah, and this is not on that data set.
No.
This is on.
This is our division and a plug.
Yeah, your split. Okay.
Yeah. Sam, do I mention about?
So here we plot the metric scores, the SARI score and the bird scores first, based on the epochs. What we can see that is interesting mostly is the BART score in SARI that is like going up quite impressively after it's starting to be fine-tuned on the PLABA dataset. And on the right-hand side, we also can observe that the BERT score of the BART-based model is quite low compared to the one of T5 and Sci5 base. So here we can start seeing that there might be some trade-off using each of those models. There might not be one best model in here, but we will come back to it later. Then we can see the blue and rouge score of both T5 base and BART base. An interesting thing here, why this has been plotted, is that we can observe the rouge and blue score going down through the epochs, while the SARI score is going up, and that is the case for both BART and T5. So here what we were thinking is that blue and rouge might not be very good metrics for this task. SARI might be more interesting for it. And a reason for this might be because of models generating output, which is exactly the same as the input. So in terms of n-gram, it might be similar to the reference, but it might just be a copy of the input. So that's a theory we had about it. That is why also we think SARI is a good choice here to select the model later for human evaluation. And just to add a little thing, BERT score here is not really to know how good is the quality of the generated output, but more to know how the meaning is preserved through simplification.
Okay, let's move to human evaluation.
So based on the automatic evaluation we got before, we choose the T5 base and the bar large with current tokens. We got birth score of 72 and salary score of 44 from T5 base, and did we? And for the bar large with current, yeah.
Yes.
So what do you mean here by human evaluation? Maybe you need to say that.
Okay, so we did internal human evaluation with 4 authors, just to decide which one to submit as the top or the primary model to submit, because the organizer will only human evaluate the primal submission.
So basically we run different models. We can submit different run. However, the organizer only selects one model per team for human evaluation. So to do that, we want to do human evaluation between us and choose which model is better, because we don't fully trust the automatic score. Is it clear?
Good. How they select which one they're gonna evaluate? The organizers.
So we select these 2. Jeremy, explain why we select these 2.
Yeah, basically these are the 2 with relatively highest salary score with acceptable birth score.
Right, but would organizers evaluate the one that you tell them to evaluate, or they will choose one based on some other metric?
We tell them.
We give them one, actually.
Yeah, we can give any 3 submissions, and we have to choose one of our main submission. Yeah.
Okay.
Did we submit 2 models or 3?
Just 2.
We didn't submit GPT model. Okay.
Actually, I think we did. No?
We submit the science T5.
We did
science 5.
Okay.
Oh, and sci-fi.
Yeah. So when the GPT produced
because we got the result later, right?
Okay, yeah.
From GPT-4, because at that time GPT-3.5 ChatGPT is not very satisfying.
We can submit next year the GPT.
Yeah. So it's about our human evaluation setup. We randomly sampled 80 sentences from the test set, and we had an evaluation form. We randomly assigned these 80 sentences into 4 forms with 50% overlap. So each sentence will be evaluated by twice. And can you just jump to the so here is one example of our evaluation form. We have the original text on the left, and then in the second column we have the 2 system outputs parallelly, so the annotators can compare them directly. And then later we give the 2 questions to answer, whether the first one is, to what extent do you agree that the sentences can preserve the main meaning of the original sentences? The next one is, to what extent do you agree that the sentence is real simplified? And annotators can choose from strongly disagree to strongly agree. Yeah. So this is the official guideline for the human evaluation, and I think they release this later.
Yeah, this is, I think they will carry out human evaluation, the organizers, according to sentence simplicity, term simplicity, term accuracy, fluency. And then for up to 3 sentences that answer the questions or are most relevant to it, from consensus of annotators there to completeness and faithfulness. That is what we think the organizer will organize the annotators carry out according to this one.
So here are the 3 forms of our evaluation outcome. The first one is evaluation scores directly based on the 5 Likert scale. So for meaning preservation, for annotators believe that the bar with control tokens is performs worse than T5 base, but in simplicity, on the contrary, the BART wins the T5 base. And later we did two calculation about the internal rater agreements. The first one is based on the Cohen kappa among annotators over the 3-category ordinal, which means the model 1 win, the model 2 win, or a tie. So in this one, we can find that only the annotator 1 and annotator 2 can reach a relatively higher agreement on the meaning preservation. And between annotator 2 and 3, we have some disagreements. The other table is based on the Krippendorf alpha, which calculates all five Likert scale from strongly disagree to strongly disagree. And both tables show some similarities, and we found we still can have the highest agreement between annotator 1 and 2. But we can see that for annotator 2 and 3, we have some disagreement on the meaning preservation from T5 base, and also some disagreements in simplicity for BART with control tokens.
So here's interesting, like from this two inter-rater annotator agreement matrix, you can see from Cohen kappa, there is some agreement between annotated 1 and 3 and text on simplicity, but from Krippendorf kappa, Krippendorf alpha, you cannot see this information between annotated 1 and 3. Instead, in Krippendorf alpha, it cites the agreements on meaning preservation between 1 and 3. So that is opposite thing between these two agreement matrix. So we think these two matrix actually do not agree with each other in some situation. There is some work that we can carry out where we want to do a PhD about improving the agreement matrix, how to make a more trustworthy matrix for measuring annotated agreement levels. And we have interesting findings. Sam, you want to mention?
Yeah. So here we will talk about a few examples that we observed when using our models. So first, it's an example of when the two models give different outputs, but one give a copy of the input text, and the other one did a simplification, but it also introduced errors at the same time. So here we have a source sentence, which is a national program of neonatal screening for CAH would be justified with reassessment after an agreed period. So the BART model will simplify it as a national program of checking newborns for COVID-19 would be a good idea. And T5 base would simplify it in a national program of newborn screening for CAH would be justified with reassessment after an agreed period of time. So here, BART is talking about COVID-19, while CAH doesn't really mean COVID-19. It means congenital adrenal hyperplasia. So it's introducing some errors. But T5, on the other hand, just creates almost a copy of the input text. So in this case, we would have problem when doing evaluation because, I mean, one keep the meaning and the other one simplifies, but.
So here,
sorry, in the original abstract or simplified text, was CAH expanded?
No.
Okay.
So here we want to say that.
Yeah, BART is trying to is trying to expand it, but it's replacing it with a wrong term.
So here what we want to say is BART made effort to do simplification for CH, but it's simply wrong into COVID-19. But it didn't make effort to do simplification of the sentence. However, for T5, it copied sentence, just added of time in the end, instead of agreed period time. So here, if we do separated evaluation from median preservation, T5 will be score the full score. Let's say if we 0 to 5 is 5. But simplification, it can be 0 because it didn't do nothing. And then birds with control tokens, the meaning preservation will be lower because it introduced new meaning. And simplification, people can say it's simplified. So for specific criteria ranking, like for selection, like meaning preservation and simplification, we know who is better, who is worse. But if we give people to use model, sometimes we have, let's say, average the score. Then when we average score, they might get the exactly same score, even though T5 actually just copy the sentence in this case. So that is thing we want to say because it's interesting for applications, and it's a cost discussion for application, like which model you will pick if we use scores. And then we have, let's see. We have another example that is, Sam, you were mentioning.
Okay, so here we have another example of such an issue. So here we have abbreviation caused interpretation inaccuracy. So we have an example. A source sentence is a total of 150 consecutive patients underwent TKA, n equal 18, or UKA, n equal 139. The BART model will simplify it as a total of 150 consecutive patients underwent knee replacement or knee replacement. And the T5 Bayes model will simplify it as a total of 150 patients had either knee replacement or knee replacement surgery.
Yeah, so here...
Does it matter, do we know what a consecutive patient is?
We don't.
I don't know.
No, because neither do I.
Yeah, we might think about it. Well, here we want to mention, from a last example, we can also see the abbreviations cause problem. That's we also say that's probably a main issue in this task. And here, both two models made some, let's say, hallucination, like knee replacement or knee replacement, because both of them didn't understand the difference between TKA and UKA. TKA is total knee replacements, and UKA, I guess, is
unicompartmental knee replacement.
Unicompartmental knee replacement. Yeah. So because the model cannot understand this abbreviation, it causes this hallucination output from the trained model.
If you are,
One second.
if you ask the model to expand acronyms before you simplify, can it do it?
That's a good idea. So we can introduce, we discussed this, we just didn't get time to implement. So we want to introduce some dictionary or some knowledge base to the model, for example, to replace abbreviations into full names, or can do extra knowledge graph, or we call the domain specific dictionary. We can, if we
can add it to future work, probably.
Yeah, we can.
The famous future one.
Well, it's not only famous future, but we also discussed it, but we didn't get time before the submission.
Yeah, we actually discussed it, but didn't have time. Yeah.
Yeah, because this girl from Germany, she presented. She used this knowledge base, like not SMIC, but something else, UMLS or something.
UMLS, yeah.
So she did this extra knowledge into the
before giving it to the model.
Yeah,
and that appeared to work, did it?
At least she finished her thesis. And she graduated. Okay, we are finishing this, wrapping up. So we
Current question.
Goran?
Well, it wasn't a question, it was what Robert said. Okay, thank you, Robert.
Yeah.
I think I can more or less the same comment.
I think we can probably skip this for time, but basically here are some other points of what happened have to be wrong with both models.
Yeah, sometimes they simplify exactly same. That's really weird. They both did simplification, but exactly same output.
And wrong outputs.
Sometimes it's correct.
Sometimes it's correct, but sometimes it's wrong.
We try to categorize the output of these kind of models. We
Mhm.
hope it will be insightful for future researchers to tackle some of them.
And here are
And,
some examples.
Yeah, if you want to read our paper, there are more examples you can read. In conclusion, Samuel.
So in conclusion, what we can see is that for thematic evaluation, BART achieves the highest ARI score, which is quantifying the generation quality to reference. But however, it lags behind T5 and BERT score, which measure the meaning preservation after simplification. And the human evaluation also goes in this sense because BART achieves higher simplicity while T5 achieves higher meaning preservation. So what we concluded of this work is that the T5 model prioritizes meaning preservation, while BART tends to favor more substantial simplifications. So it might simplify more, but to the cost of also introducing some errors.
So for future work, we want to try different efficient training methods. For example, this work we use LoRa. For the recent year, there are other different efficient fine tuning. For example, adapter a bit older than their prefix fine tuning. So we want to try them and the reference in our paper. And for human evaluation, we want to think about how to address the low inter-agreement levels between different annotators. And we might need to re-annotate some of the tasks. What's this?
So we'll turn to
Can I pass the remote again?
Why is everyone quiet? Li Feng, you're muted. Guys, you're muted. We can't hear you. Much better now. Thank you.
So yeah, I was saying T5 and Sci5 use the prompt summarize because it was pre-trained on this prompt.
Okay,
Yes.
fair enough.
So there's other prompts, but
Yeah.
for our task, it's the one we use.
But still, you can fine tune it with the prompt simplify, right?
45.
There's no prompt simplifier, I believe.
Yeah,
Is
but
there?
you can define it because.
Also, I tried.
that.
Yeah, I tried. I also tried to do it just sequence to sequence,
Yeah.
no prompts. But the result we had is the summarized one. It was the best.
Okay.
Yeah.
But obviously you can play around.
I tried. Yeah, I tried. Of course. It's the one I did first, actually. The sequence to sequence without any.
Add that to the paper.
Okay, I can.
Right,
Yeah.
that was really interesting,
Thank
thanks.
you, everyone.
Thank you, everyone. For people online, you can still ask questions if you want.
Yeah, I think Most people left, so thank you guys. Good work.
It's a biomedical abstract data with Blabla. It's the public. Also, you can can you send me the other?
That sounds interesting. Yeah, I'm a really new graduate.